Can the actual pattern of a plow, just the way you drag steel through the dirt, literally drought-proof a landscape? I know, it sounds a bit wild, right? But today, we're diving into exactly how a totally unique concept in hydrological engineering can do just that. We're going to see how shifting just a few lines in the dirt can solve some massive ecological problems, from severe erosion all the way to catastrophic droughts.
Welcome back to The Explainer. I am so glad you're here for this one, because today we're unpacking the absolute genius of P.A. Yeomans and his completely groundbreaking concept known as Keyline design. We're going on a bit of a spatial journey. We'll start way out at the macro landscape level and then zoom right down to the specific topography of a single hillside. We've got to see exactly how water moves and, more importantly, how we can actually manage it.
Okay, let's dive into this. Here's our roadmap for today. We're going to look at the scale of permanence, the problem with valleys, finding the key point, the keyline solution, and finally, restoring rangelands and pastures.
Section 1. The scale of permanence.
To really grasp keyline design, we've got to travel back to Australia in the 1950s. That's when Yeomans developed this foundational mental framework for looking at land. It's called the scale of permanence, and it basically ranks environmental elements based on how difficult and energy-intensive they are to change. Right up at the top, climate. It is the least flexible. You can't just snap your fingers and change your regional rainfall. Right below that, though, are land shape, so topography and water supply. Since these massive structural drivers are incredibly hard to modify, they absolutely have to dictate where we put the more flexible elements further down the list. Think roads, fences, and, believe it or not, soil. Yeah, soil is at the very bottom. It's actually the most flexible element. We can build soil fertility pretty quickly, but only if we align our design with those permanent drivers at the top, the natural shape of the land and how water flows across it.
Section 2. The problem with valleys.
So this brings us to a natural conflict built right into every single landscape. When it comes to water management, gravity and natural topography kind of act like the villains of our story. They naturally mismanage the rainfall. And what's really fascinating here is the stark contrast between the extremes. Look at this dynamic between valleys and ridges. Ridges are naturally convex, meaning they bow outward. Because of that shape, they shed water and are basically always prone to drought. But valleys, they're the exact opposite. They are concave, dished inward, so they aggressively collect and concentrate all that water, making them super prone to erosion. This right here is the exact geographical problem Keyline design solves. We have way too much water tearing through our valleys and nowhere near enough water up on our ridges. To understand exactly why this happens, we just have to look at the basic physics of water. Gravity forces water to flow downhill, specifically moving perpendicular to contour lines. Imagine you drew perfectly level rings around a hill. Water is always going to flow at a strict 90-degree angle to those rings. It takes the fastest possible path, straight down. And because of that, during a heavy rainstorm, natural runoff rapidly strips the convex ridges of their moisture and violently funnels it down into the concave valleys. The result? Destructive sheet erosion, massive headcuts, and a landscape that is somehow simultaneously parched and literally washing away.
Moving on to Section 3. Finding the key point.
To fix this whole valley problem, we have to zoom our spatial journey in a bit. We're looking closely at the profile of a single slope to find a very specific, absolutely crucial topographic feature. We're looking for what Yeomans called the key point. Imagine you're walking down a hill. Up at the top, the hill is convex, right? It's curving outward, shedding water. But as you keep walking down, the hill eventually flattens out and becomes concave, curving inward to form the valley. That exact point of inflection, where the slope completely transitions from convex to concave, is your key point. Visually, you can usually spot it because it's the very beginning of a visible erosion channel. It's the exact spot where subsurface water running through the hill finally breaches the surface. It acts exactly like the end of an open pipe pouring right into the valley.
And once you find that key point, you can map out the key line. The key line is simply the unique, perfectly level contour line that wraps around the landscape and passes directly through that key point. So why does this one single imaginary line matter so much? Well, in Keyline design, this specific contour line becomes your foundational geographic guide. It's the master line. Every single decision you make regarding water management, earthworks, cultivation, literally everything across that specific valley is dictated by this one phenomenal line.
Section 4. The Keyline solution. So the crucial question is, how do we actually utilize this keyline? How do we take an invisible line on a map and use it to actively fight gravity and fix that massive imbalance between our wet valleys and dry ridges? Well, Here is the absolute brilliance of Yeoman's engineering. The solution relies on a very specific cultivation process. Step 1. Locate the key point. Step 2. Map the key line. Step 3, and this is where the magic happens, you plow the soil parallel to that key line. Since natural contour lines are almost never perfectly parallel to each other, when a tractor drives perfectly parallel to the key line, it is actually forced to fall slightly off contour. What this does is create a massive subsoil distribution network of plow furrows. And due to the geometry of the valley, these parallel cuts actually slope gently upward as they move outward from the wet center of the valley out toward the dry ridges. This plowing pattern perfectly enacts that classic permaculture mantra: slow, spread, and sink. When a huge rainstorm hits, instead of all that surface runoff violently rushing down the center of the valley, it gets intercepted by these off-contour plow lines. These subsoil channels physically grab the water, fight against natural gravity, and gently direct it laterally. It moves the water completely out of those saturated valleys and carries it outward to hydrate the dry, thirsty ridges. It's amazing. You are literally combing the water across the landscape.
Section 5. Restoring rangelands and pastures.
Now let's zoom back out to the macro level to see how these topographic principles scale up. When we apply these exact same mechanics to expansive rangelands and pastures, we can solve massive regional drought and erosion problems. Large-scale watershed groups like the New Mexico Water Resources Research Institute approach restoration with one primary goal: keep water, sediment, and nutrients on the landscape. Stop watching them wash downstream. Instead of just deep plowing, they use shallow, porous terraces, stone lines, or half-moon-shaped berms, which are beautifully called media lunas, to spread overland flow right along the contours. They build passive ponds. The whole objective here is to mimic the natural overbank flooding that used to happen naturally before human intervention. They're basically using the landscape's natural geometry to catch the water, slow it way down, and force it to sink in. And this brilliantly illustrates how the physical, structural water distribution connects directly back to biological soil health. It creates this incredible feedback loop. By intentionally spreading water out to the ridges and sinking it into the ground, you drastically increase soil moisture. That moisture supports the rapid growth of strong, deep-rooted vegetation. And then that new vegetation acts as a biological sponge and a physical barrier to future storm flows. So you get even more water infiltration, which grows even more vegetation, which permanently halts erosion and totally diminishes flood energy. You're literally healing the entire watershed from the ground up.
The Yeoman's Plow Company really hits the nail on the head with this quote. The Yeoman's Keyline system is a practical approach to improving soil health, water use, and farm productivity by working with the natural shape of the land. And that's really the core philosophy of our explainer today. True ecological resilience doesn't come from forcing our will upon the land or trying to fight gravity with massive concrete dams. It comes from working intimately with, rather than against, the natural contours and physics of the earth. By understanding the scale of permanence and actually learning how to read the ridges and valleys, we can partner with nature to turn a degrading landscape into a thriving one.
So, I want to leave you with this final thought. The next time you take a walk or drive through your local area, really look at the hills, look at the valleys. See if you can spot the convex ridges and the concave dips. Where are the key points? How might identifying the natural key lines completely change the way you view the water flow in your own local watershed? It is a brand new, highly analytical way to see the world around you. Thanks so much for joining me on this explainer, and keep observing the incredible patterns of our natural world.